Hey guys. Okay, this is the turning point formula. Few things are changing. Before we go to changing, the turning point formula gives you your turning points by looking at the formula. But there's a few nutty grits. Um, Let me hold it like this. The thing is misbehaving. I don't know why. There we go. This is the 10th recording, by the way, because it's misbehaving now. I think it's tired. Anyways, there's a few things that are changing in this formula. In the previous formula of y is equal to ax squared plus bx plus q, we remember that q was the y-intercept. In this case, it's not. In this case, q is now the y value for a turning point. Remember, a turning point or any coordinate needs x and y. Q is now y. Does that make sense? P, on the other hand, now becomes the x value for turning point. Okay? But now there's a catch, and I'll explain this catch. When my p is a positive, so in the equation, if I have x plus 3, the coordinate is not 3. The coordinate is negative 3. Why? Let me explain it like this. To understand me, this is the best way I can explain it. You have x plus p is equal to 0. X is equal to negative p. So the x coordinate is actually negative p. So if this is the formula, right, then it means according to the formula being written like this, my turning point will actually be negative p and q. Okay. But if p was a negative, so if I had the y is equal to a x negative p squared plus q, then we say x minus p equals 0. X is equal to p, so p is positive. So we are saying p the whole time. So then my coordinate will then be p, q. And q is q. Q is not two-faced. Q is q. Doesn't appear positive but it's negative. Doesn't appear negative but it's positive. If q is negative, negative q. If q is positive, just q. Okay. What you need for this formula is on the graph, you need to have the turning point. But now we'll get to how you write the turning point down. You need to have random coordinates. Just like the previous formula of the x-intercept, you must first find a. Now, what they can do is, let us use in this case, which is going to be a long method. I'll explain it. We'll use the previous example and we should get the same answer. Let me just zoom in. What they can do, they gave you a random coordinate, right? Which is going to go between y and x. They gave you two x-intercepts. Just a quick note, write it somewhere in your notebook. The turning point or the x value for turning point, remember we said can be calculated using negative b over 2a, but it can also be calculated by using the x-intercepts. Did you guys know that? So what now is going to happen, we're going to say r1 plus r2 over 2 will give me my x-intercept for thee. And once I have my x-intercept for thee, then you can carry on. So what they do is they give you the y-coordinate, not x-intercept, x-coordinate, I'm tired. They can give you the y-coordinate there for this graph and not give you x, but they've given you x-intercepts. And you will have to use this to calculate whatever's happening there. We'll make an example using this guy. Before we go there, let's make an example using this guy. So we are given a turning point of 1 and 4, a random point of -1 and 16. Now, let me zoom out. Now, there's a certain way that we are going to write this thing down. Let's just write the formula there. We have y is equal to ax plus b squared plus q. We have a random point. If you just rewind a bit, we have a random point there of -1 and 16. So y is 16. We put y there. Y is 16. We're going to solve for a. We do not know what a is. We know that x, the x random x coordinate is -1. Now, key point. The y point, or the x point rather, for the turning point is 1. But remember when we said, when the x point for the turning point is positive, it's going to go in the equation as x negative b. Right? So it's going to go in the equation is -1. Right? Bracket squared. Q, if you go back, we find that the y value is 4 plus 4. -1 and -1 is -2. -2 squared is 4. 4 times a is 4a. Plus 4. That plus 4 is not part of the square. It's a term on its own. Do not add and say 8a. It's 4a plus 4. So now this will become 16 minus 4 is equal to 4a. Then we will find this is going to be 12 is equal to 4a. Right? 12 divided by 4, we will find that 3 is equal to a. Now, a is positive. Your graph must be smiling. The graph is smiling. Okay. Then what do we do now? So now, what we can do is substitute back, but without any random point. So we're just going to say y is equal to 3x -1 squared plus 4. They can say leave it like that, right? Or they can say write it in this form. If they say write it in this form, it's very simple. It's not rocket science. It's going to be 3x minus 1, x minus 1 plus 4. This is multiplication on its own. So you multiply everything there, and then you plus the 4, you should get a beautiful, lovely, lovely, nice, sexy answer. Okay. Last video for today. Random point, 5 and 11. Turning point, 1,75, -10,125. This was the first ever example we did. I want to see if we are going to find the same or close enough to. But it didn't round off, so we should find close enough to. First thing you do is you see I'm given turning point and some random coordinate. First thing, your brain must just click, must happen like that. You are going to go and say y is equal to x plus b squared plus q. Right. Random point for y is 11. So we're going to put 11 there. We do not know what is a. So we say a. Random point for x is 5. But now check. X is on the positive side. You might be tempted to say plus 1,75, but it's negative 1,75 because we work with opposites in this formula. If the x value is negative, plus, positive, negative, squared minus 10,125. Now if you type in that big mess, you're going to find 169a over 16 minus 10 comma 125. Remember what I said? That is a term on its own. It has nothing to do with that. Now, plus goes that side, becomes positive. So we will then have 21,125 is equal to 6169 over 16. Okay, if I were you, what I would do is I would multiply that side. So I'd have 16 times 21,125 is equal to 169a, and divide by 169, divide by 169. And when we do that, we get a beautiful answer of 2 is equal to a. A is positive. My graph must be smiling. Is it smiling? Oh yes, it's smiling. Okay. Now we go and say y is equal to, we know what a is 2. We don't substitute any random coordinates. Negative 1,75 squared minus 10,125. Very simple, guys. That's going to be equal to 2 times x minus 1,75 x minus 1,75. These are on their own, minus 10,125. Sorry. If you multiply this big mess, you should get a lovely answer of y is equal to 2x squared minus 7x minus 4. That is my last video for today.